Hello and welcome back to my channel, Java with Ali, and I am Ali, and today we are going to talk about data structures. A few people have messaged me about trying to get in contact with doing data structure videos, so we are finally on the topic and we are going to talk specifically about dynamic data structures, and this impacts your compile time on your computer, and they grow and shrink at execution time. So linked lists, for example, are linked up in a chain, which we saw a little bit of linked lists already. Their insertions and deletions can be anywhere in the list. Then we have stacks, and if you remember my data structures video, the stacks meaning the stack like a stack of plates, and you push on and pop off. So you pop off the top, you push it on, and then so basically insertions and deletions are only made at one end of the stack. That's the important part for stacks, and that's at the top. So you pop on and push off. And we demonstrated that with the plates already. Then we have a new data structure called a queue. So in Irish English or Hiberno English, we use queue to mean line in American English. So if you're in a line or like a waiting line, then insertions are made at the back, just like when humans queue. And that's also referred to as the tail of the queue, and deletions are made from the front, also referred to as the head. So a queue, obviously, you join at the back, and then like you address the person at the top of the queue or whatever. Just say, for example, it's a person, and then you remove them at the top of the queue. So that's the head. Then we have binary trees, which we spoke about already as well. And binary trees are super fast. They're the high speed searching and sorting of data. They eliminate duplicate data items, and they're efficient and representing of like file system directories, compiling execution time, and machine learning and everything like that. So now we are going to start programming. We're going to have a look at list first, and I'm going to pause the video now, open up Eclipse, write out some code, and you can see how a list looks like. So let's see in a second. Hello, welcome back. So I am going to talk to you about lists, and we're going to specifically talk about linked lists. And here we have, if we look over here, we have three different Java files. One is a public class called list, and it's a generic type. Part of the package structures, and we also have list node, which is also part of the package, which we'll come to in a second. And we have first node and second node, and then a string called name. The constructor is list, this list. A next constructor is string, and it takes in the variable and then assigns whatever variable when you call the list to the name within this class. And so on. You can kind of interpret the rest of the code yourself because it's standard now with setters and getters and constructors. If you're unsure, please check out the constructors video. Then we have public void insert at front. So we again use generic type. We insert the item. So whatever generic type this is, it's going to be called insert item. If it's empty, so is empty can always be used as part of list, we know. So this first node, so we're going to say insert item new list node new is equal to this last node, and we're assigning it to the first node, and so on. So if we go down here again to insert at back, also similar. Remove from front is going to be removing it. So we're going to do some checks first. We have the no such element exception, which is almost always through it. This is just an introduction. So I'm going to put this code up on GitHub, and in the next video we'll go through this again because we're going to use these as our like core Java files to test different types. So here again we have our generic type, and it's our removed item, and we're going to take the data dot first node, this, assign it, then check last node if it's equal to the first node, and then do a check if it's null as well. So here is an important part. So the generic class list node, which we're going to open up in a second, it allows for package access data fields, and these are next node. So the data field is referenced with E. If you're unsure of generic types, please check them out. So its type will be determined by the client code. So whatever you type in when you make a reference, if let's say we're going to use int, then it will change it to an int generic type. So it will change it to an integer generic type because we need to use it has to be boxed into an object. So its type will be determined by the client code corresponding, which creates the corresponding list object, and the variable next node is also stores a reference to the next node. So if we go now to list node and then come back again, you can see here that we have our data because we're talking about it now, and then we have next node, and you can see then through here that we have our different constructors when we call list node within the package structures. So we take in a generic type and then we again call the next list node variable and the generic type again, and we assign our variable to data and our variable 2, which is our list node generic type, to next node. So with linked lists, an important part about anything to do with data structures is to do with dynamic memory allocation. So we have our physical memory in our computer, and when it runs out of memory, you'll know about it. But let's say linked lists then are used to expand and shrink based on what's needed. Now you're thinking, but array lists do the same thing. Yes, they do, but these are super duper fast and they're part of a data structure, which will come through to the advantages and disadvantages in another video. However, yes, you're right, array lists do grow and shrink based on the need as well. So like we know already that an array is a fixed length. An array list can shrink and grow. A linked list then can be added to at any point in the list. So then we have our constructors which both initialize to null. The most important methods of class list then are insert at front and insert at back, and then remove from front and remove from back, which we'll come back to now. And the method then is empty. It's a predicate method that determines whether the list is empty. So predicate methods typically test a condition, and they do not modify the object that they're called. So it's true or false is empty, otherwise it returns as false. So here we have our remove from back with our no such element exception, and we have our is empty, which is down here, and our print, because we want to print them out as well. So when I go then to class list test, it takes our lovely wrapping of our primitive values and putting it into an integer, taking our primitive type int and putting it in an object. So we're using the boxing again because we need to do that for generic types. So we are going to insert integers in the list by using the insert at front, insert at front, insert it back, and then we're going to remove them. So we're going to use a try catch here. So we have our remove from front, remove from front, remove from front. Now I've just done the remove from front in these, but you can experiment with the code yourselves, and we'll have a look now when it runs. It takes a bit of time with this computer. So list test calls list method print to display everything, as we know. So here we have the list is -1. So if I make this a little bit smaller, then we can go through the code a little bit here. So here is our list is at, let's keep the console up. you can see here that it's -1, 0, so it's inserting it at the front. Inserting it at the back then is going to insert it there, and inserting at the back then is going to be, so it's 0, -1, 1, and 5. 0 is removed, -1 is removed, and 1 is removed, so the list is then left with 5. So that is our really short introduction to some data structures. So this is just concentrating on lists at the moment, linked lists specifically. We have our linked lists, we have our stacks, we have our binary trees, and we have our queues. Queues like the line in a queue, where you have your tail added at the tail, removed at the top. Then we have our stack, which is our last in, first out. So our stack of plates, if you imagine the stack of plates like this and you push on, so you push it onto the top and you pop it off the top as well. Then we have our linked lists that can be inserted at any point, and they can expand and shrink based on our needs at execution time from the client when it's called. And most importantly, we have all of these data structures that are going to impact our dynamic memory allocation. And with our dynamic memory allocation, we need to know most of this due to the physical memory, and also what are the needs that are going to be met with our computer. So here, if we go back to list, this is our core Java files that we're going to use also in the next video. So bear with me now, because we're going to just touch on this topic and then go on to the next video and go into a little bit more detail. So as you can see, we have our generic types here. E for remove from front, so we don't need to keep repeating everything. So with generic types, just to reiterate, the reason why we have generic types is to do with method overloading. Method overloading is when you can write multiple methods of the same name, but their signatures are different, so the arguments within them are different. Here we have generic types because we can use one method to take on a different type for each, which is really nice. It allows the code to be a little bit more flexible. It also allows for less written code, and you can just declare the one method and also call that same method multiple times. If you're unsure about generic method or generic classes, please check out the video. And thank you so much for watching. Happy Sunday, and please subscribe to my channel. Thank you to all who have subscribed so far. I'll be making more. Please send in your requests for any more types of videos that you want me to add as well. And thanks for watching. Bye.